So I want to run through a little bit more of a complex example in SPSS because it's going to let us look at all of the steps through this process. So we have a researcher who has basically got a sample of zoologists, historians, and psychologists who either own a Labrador Retriever, a German Short-Haired Retriever, or a Golden Retriever. And he has the outcome of their personal stamina. So he's looking for the difference between profession, zoologist, historian, and psychologist, dog breed owned, Labrador Retriever, German Short-Haired Retriever, or Golden Retriever, on stamina. So if we put this in terms of an ANOVA, it is a 3, zoologist, historian, psychologist, categorical IV1, by 3, dog breed, independent variable 2, Labrador Retriever, German Short-Haired Retriever, or Golden Retriever, factorial ANOVA, on stamina as the outcome. So a 3 by 3 ANOVA looking at stamina. So let's walk through what we'd actually need to do in SPSS to analyze this data. And there's a fair amount of steps to make sure we're getting the information that we need. So the first thing, of course, is we'd have a data set. We would have a column for dog, a column for owner, and a column for stamina. And under dog, we'd have it coded 1, 2, and 3 for the 3 different types of dogs. Under owners, we'd have it coded 1, 2, and 3 for the 3 different types of major. And then we'd have their stamina scores. So once we have this data set, we'd hit Analyze, General Linear Model. Notice ANOVA isn't listed here. The General Linear Model is getting you to the analysis that we need to run an ANOVA. And then we're going to simply choose univariate. Univariate because there's a single outcome variable, stamina, and it's continuous. That's going to take us to this table, and we're just simply going to tell SPSS what we're doing. The dependent variable is going to be that continuous variable. We're going to click on it and click it over, and that's stamina. And then we're going to click our 2 IVs. In this case, according to SPSS, they're fixed factors. We're going to bring those over to the second box, fixed factors, the owner, and the breed of dog. Once we have that information clicked over, we're going to hit post hoc test because, again, we need post hoc test in this case because both of our IVs have more than 2 levels. So just because the omnibus test tells us there's a significant difference, we don't know where that difference is. So with the post hoc test, we're going to pick our 2 variables that are 3 or more levels, bring them over to post hoc test, and we're going to click 2 keys because that's the one that we're going to use in this particular case. You'll notice there are a lot of different types of tests that we can use, and there are different specific situations where each of these tests may be used. But for the most part, we're just going to stick with 2 keys as we're familiar with what it is. It's the most appropriate test for most data sets, and it's the one that we're more familiar with. We're going to click Continue. Then we're going to click Plots. This is going to give us a visual representation with the data. Once we've clicked Plots, we're basically going to select our independent variables. We're going to select the first one and click it over to horizontal lines. We're going to click the second one and click it over to separate lines. If we had 3 or more, we might also be doing separate plots. However, in this case, we still have only 2 variables, even though they're at 3 levels each. And then we're going to click Add to both of these and click Continue. And that's simply going to tell SPSS to give us a physical or visual representation of what's going on with the data. This will bring us back to our ANOVA table where we've been adding everything in. We're going to click Options. And this is where we're going to tell SPSS that we also want descriptive data, but we also want to check our assumptions. So we're going to select all of our variables, overall, owner, dog, and the interaction. We're going to click it over to display means for, and then we're going to click descriptive statistics. This is going to tell SPSS to give us means and standard deviations. We're also going to collect an estimate of effect sizes. This tells SPSS to give us that partial eta squared. And we're going to click homogeneity test. So this is going to make sure that the variance between the various groups, regardless of the means, is relatively the same. And we're going to click continue. We're now ready to let SPSS do its magic and run all these calculations for us. So we're going to click OK. So here's the first set of readouts we're going to get from SPSS. Notice we're going to get Levine's test for equality of error variance. This again is a test that we want to see as insignificant. In other words, we want to see a significance of above 0.05. In this case, it's well above 0.05. Homogeneity, the assumption is met, and it's appropriate to look at the data. If it wasn't, that's something we can look at in more advanced analyses. However, from this point, most of the factorial analyses we're going to run are probably going to have sphericity assumed. We can move forward. We're then going to get this table, which is going to include our degrees of freedom, our mean squares, our F, our significance, and our partial eta squared, our effect sizes, if you will. So it's going to give us our main effect for A, our main effect for B, and our interaction, along with our error degrees of freedom. So again, remember that our degrees of freedom here for our two individual conditions are 2 and 2. That is K, the number of conditions, 3 in both cases, minus 1. And our interaction is going to be those 2 degrees of freedom multiplied by each other. K minus 1 times K minus 1, so 2 times 2 is 4. We're going to have our mean squares. Dividing our mean squares by our degrees of freedom is going to give us our F. That F is then going to be looked at for its significance. So we look at our main effect of A of owner, a significance of 0.456. There is not a significant difference across the owners. So we don't even need to look at partial eta square. However, there is a main effect for dog. So we do find an effect there, significance of 0.00. So we report that as P of 0.001 with a partial eta squared of 0.35. So that's a fairly large effect. And finally, we can look at the interaction. And here, the F is 0.486. The significance is 0.746. There wasn't an interaction. So again, we don't really need to worry about the partial eta squared there. So in this particular data set, all we have is a main effect for dog type. So we're only going to check the post hoc test for significant effects. So we don't really care about the differences that we're looking at. We don't look at the differences, and we will get a table, by the way, of post hoc tests for owner. But what we're interested in is breed of dog. And what we're going to see here is the tests, Labrador Retrievers versus the other two, German Short-haired versus the other two, and Golden Retrievers versus the other two. And we're going to look for those significant differences. So we're going to find that there is not a significant difference between German Short-haired and Golden Retrievers. There's not a, but there is a significant difference between Labrador Retrievers and German Short-hairs and Labrador Retrievers and Golden Retrievers. So those are our significant differences, and they're showed with our significance here. So again, if we looked at our means and standard deviations, we'd have our descriptive statistics. And this basically, again, we have our total. These are our actual marginal means. So if we look at the difference between dog types and historians, dog types and psychologists, and dog types and zoologists, we have our owner's means. So the means of historians across the 3 dog breeds, the means of psychologists across the 3 dog breeds, and the means of zoologists across the 3 dog means. We also have the actual dog mean total. So this is our separate set of main effects. So again, we have the average mean of Labrador Retrievers regardless of owner, German Shorthairs regardless of owners, and Golden Retrievers regardless of owners. So again, we have all this information provided in this particular table. So how we'd actually report this is a 3-owner, zoologist, historian, or psychologist, by 3 dog breed, Labrador Retriever, German Shorthair Retriever, or Golden Retriever, Factorial ANOVA, was conducted with stamina as the outcome. There was not an interaction between the expertise of the dog owner and the breed of the dog with regards to the dog's stamina. Again, we'd report this, P of 0.75. Nor was there a relationship between the main effects of the owner's expertise and dog stamina. And again, we'd report that. Notice in these 2 reports, we're not including effect size. They're not significant. We're not moving forward. However, there was a main effect relationship between the breed of dog and stamina. We report the significance there. Tukey's post-test tests found that Labrador Retrievers had greater stamina than either German Shorthair Retrievers or Golden Retrievers. However, there was no difference between German Short-haired Retrievers and Golden Retrievers with respect to stamina. If we did have a significant interaction, we would need to do simple main effects tests. And this is a little more difficult in SPSS. It is to be used when there's a significant interaction. And in order to do this, we're going to go to New, File, New, Syntax. And we're going to basically cut and paste the bottom section here, changing out anything in red. So we need to tell SPSS to basically do the simple main effects. In other words, do these comparative ANOVAs. So we're basically going to be using the equation that we have down here and plug it in. However, we're going to change. So for example, here our DV name is rating average. You would use whatever DV name you've used in your data set in this place. And then we have by, and then our 2 independent variable names. So vid condition and accountable in this case, again, we would change the 2 of these to whatever you used for your IVs. So for example, if your DV was stamina and your IV names was owner and dog, this would be una ANOVA stamina by dog space owner. Then we'd say E means table, dog times owner, compare dog, and then we'd have dog times owner, compare owner. So anything in red we're changing out, and then we're putting it, once we've done that, into the syntax window. Once it's in the window, we're just going to hit this green arrow, and we're going to get the analysis, and here's the simple main effect test. Now notice in this particular data set, there was not an interaction. So indeed, we find there was no significant differences. All of our significant differences are well over 0.05. But this is how we'd actually be looking at this if we were actually having to run simple main effect tests.